Hello everyone. So today we are going to cover another interesting problem, search in rotated sorted array. We have already solved two problems in similar fashion or which is related to this problem, which is check if an array is rotated and sorted and find minimum in an array rotated sorted. So you can find the link of their videos in description. So let's get into this problem now. And here the input given is an integer array which is sorted and rotated and another integer variable target. We have to search the target variable in a given array and return its index. So let's understand this problem with an example. Here is a given example where we need to search for 0 in the given array. 0 is at the fourth index or fourth position, so we have to return 4 as our output. So here, if you observe, the straight away brute force solution we can think of is iterate every element in the array, and when you reach the target, return the index. So this is going to take big O of n time, which is again a simple straightforward solution, but how to make it work even more better? The clue here we got is the array is sorted and rotated. The first thing that hits our mind if we hear a word sorted array, which is going to be binary search. So in general, in a binary search, you will be provided with a sorted array. You will just hit on a mid value. If the mid value is greater than the target, then you will be fixing the second half to search the target. If not, you'll be fixing the first half to search the target. But here the array is sorted and rotated, which means it will not be completely in ascending order. There will be an inflection point where it starts reducing. In this case, how do we approach this problem using binary search? In our previous video, we have seen find minimum in a rotated sorted array. For that, we used a technique that we have to find the inflection point. Inflection point is nothing but where the array stops increasing and we face a decrease and again starts increasing. So this point is actually inflection point. So the minimum in a rotated sorted array will be the next element to the inflection point. To find the inflection point, we actually compared a mid value, whichever is the mid value we get, with the first element. And if the mid value is greater than the first element, which means we still did not reach our inflection point, we are still in the increasing order. If not, if our mid element is less than the first element, which means we cross the inflection point. By using this technique, we found our inflection point using binary search and then found the minimum value. We are going to use the same technique here. By just adjusting few rules, we're gonna find our target instead of minimum value. It is of course going to be a better approach than brute force, but to search for the inflection point will take log n time, and after finding the inflection point, we fix which range to search for the target, whether this range or this range. So again, it is going to take one more log n time complexity. So instead of finding the inflection point and fixing our range to check where is our target, we can further improvise this algorithm by using another technique. So in this problem, we're going to get one more key. For example, in the given first array, if you hit the mid element is going to be 1. In this case, the second half is strictly increasing, but the first half is increasing to some extent, and then we face a decrease and then an increase. It is not strictly increasing. If you observe the second example, in this the mid element is going to be 6. Here the first half is strictly increasing and the second half is increasing, decreasing and then increasing. And similarly, if you see the third example, mid 8 is going to be our mid, and the first half is also strictly increasing and the second half is also strictly increasing. In this case, we can come to a conclusion that either or at least one part or one half of the array is going to be strictly increasing. So in first example, the second half, in the second example, first half, in third example, both the halves are strictly increasing. By using this clue, we are going to approach our problem. So in this example, our mid element is going to be 7. So let's solve the same example by considering our target as 5 first and then 1 next. So first we have to search for 5. So we are going to check we are on which side. That is, which side is the strictly increasing side. To find that, we have to compare our mid value with the leftmost value. If the leftmost value is less than the mid value, then it is an increasing side. So we found our first sequence is going to be strictly increasing. So we are checking whether our 5 falls between this range. To check that, we have to check whether 5 is greater than the first element and less than the mid element, which means target falls under this category. So straight away we fix our left to the leftmost and right to one element before mid. And again find its mid. The mid between left and right is going to be 4. So after fixing 4, we are checking which is greater than or less than 3. It is actually greater than 3, so it is an increasing range. We are going to check whether 5 falls inside that range. No, 5 is not falling that range. So we are incrementing our left pointer and fixing our left pointer after 4. So now search in this range and we found our 5 as the mid element and we have to return its index. This is one way. What if our target falls in not so strictly increasing side? Let's see. As I said, we are going to have our pointers left and right to the first and last element respectively, and our mid element is going to be 7. So now our target is 1. We are going to check whether 1 is existing between the range 3 to 7. No, 1 is not between the range 3 to 7. So we are going to fix our left pointer next to mid and right pointer is going to be the same. Now it's time to calculate our new mid. Our new mid is going to be 0. So now we are again going to check whether the left half is in strictly increasing order. So now our left is 8. 8 is greater than our mid value, which means we are not in the strictly increasing phase. So we have to check the other half, whether 1 exists in the other half. How do we check that? We check whether our right is greater than our mid, which means and our target is within this range. If our target is within this range, we are going to fix our left after mid again. So now we check new mid. New mid is going to be 1, which is actually our target, and we're going to return the index of 1. So the overall logic is simple. We are first going to check if we are in increasing range and our target is in that range. We are going to fix our left and right pointer to that range. If not, fix our left and right pointer in the next range. So if we are not in the strictly increasing range, then we're going to check whether our target is between the mid and right pointer. If it exists, we are going to fix that range. If not, we're going to fix other range. So let's see how we're going to code it. So let me start declaring my left and right pointer to the first and last position of the array. And my mid. So I'm going to iterate till left meets right and calculate my mid. So once my mid is calculated, I'm going to check if my mid element itself my target. If that is the case, then I'm going to return the index of that mid element. If not, I'm going to check whether it is in a strictly increasing range. So to check that, the middle element should be greater than the leftmost element. So if I entered the strictly increasing range and I'm going to check if the target is existing between that range. So if my target is less than or equal to mid value and greater than or equal to my left value, if that is in that range, then we are going to move our right pointer before mid. If not, we are going to search that in the second half. So we simply fix left is equal to mid plus 1. So this is done if it is in a strictly increasing range. If not, simply I'm going to put else. I'm not going to check any condition, because if it is not in the strictly increasing range, it is going to be the other half. So inside that I'm checking if my target is greater than the mid element and target is less than right element, then I'm gonna search in the second half, else I'm gonna search my target in the first half. Finally, if our element is not found, we are going to return -1. So let's run. So yes, our solution is accepted. So thanks for watching. If you do like the video, hit like and subscribe. Thank you.